Alrighty, so let's look at this guy, this one now. We've got 5 grams of copper was heated from 20 degrees Celsius now to 80 degrees Celsius. How much energy was used to heat Cu? Specific heat capacity of Cu is this, 0.092 joules per gram per Celsius. Okay. First thing I want to see is what does Cu mean? Okay, what is it?
Specific heat capacity.
Aha, no.
What?
Right. Cu is actually an element.
Oh.
Cu is the chemical symbol for copper. So what they're asking is 5 grams of copper was heated from 20 to 80 degrees. How much energy was used to heat the copper? The specific heat capacity of copper. So Cu is copper. That is an element to be found in your periodic table. And if for some reason we don't know what Cu is, then we go to our reference tables again. And we're going to look up on page 10 or 11. And we're going to look for Cu all day. And then where is it? Let's look at number 29 down the line. And there it is. Cu and copper. So I know that they're talking about copper, not the specific heat. The specific heat is the specific heat capacity, all right? So 5 grams, what variable should I designate that? Very good. So I'm going to put a little m on top of the 5 grams. Was heated from 20 degrees Celsius to 80 degrees Celsius. Go ahead.
The T initial and C final?
Very good. What's the T initial, the 20 or the 80?
20.
Very good, because we're starting at 20 and going to 80. So how we designate that is T, capital T, sub I, little I on the subscript. That's your T initial, your T initial, your initial temperature. Very good. So now you're in the same logic, your 80 degrees, where we're going towards, is my final temperature. We designate that as a large capital T with a sub F, like Frank, or F like final. Okay? Our T initial is 20 degrees, our T final is 80 degrees. Let's just leave that as it is because we're continuing. How much energy was used to heat the copper? I don't know what the heck they're talking about right now. I'm going to leave that to the side for a second. Specific heat capacity of Cu, which we know now is copper, is 0.92 joules per gram times Celsius. This unit is the unit that you and I derived in that last problem. That's the same thing as what they gave you. Sometimes they put joules / G and then just a little degree sign C, or sometimes they put joules slash and then grams with the dot C, and you may even see it like this, which is joules times grams to the -1 power times C to the minus degrees Celsius to the -1 power. When I do something to the -1, x to the -1 equals 1 over x.
Good morning, mister.
Good morning. Alrighty, so that's the same as that. So when we put it to the -1 power, it's like saying it's what they call the reciprocal, or 1 over. Ryan, make sure you sign in, my friend. Right in the front. Right in the front, I think, yeah. Okay, so what's the specific heat? What we're looking, we have the specific heat capacity of copper is this number. What letter is that? Farah, what letter is that? No, we're talking about specific heat capacity. What's the variable for that? Where's your reference tables? Flip it to that bottom, go down to the heat section.
Can you repeat the question again? That's C.
Very good. Very good. But did you see how you figured that out? So it's all there for you. You don't have to memorize it. You just got to know where it is. Good. All right, so that would be C. So I'm looking for the specific heat capacity, so I'm going to put the letter C there. Not to be confused with a large C for Celsius, so that's why we got to be a little careful.
We're looking for T.
Huh?
We're looking for T.
And then how much energy, Farah, what's the variable for energy? Based on your heat section there as well. Correct. What does it say for Q?
Oh, for Q, that's heat.
Okay, but what else does it say? Just says heat, right? All right, that's fair. So, heat and energy are the same. I guess you just have to remember that. So heat and energy in this case are the same. So we're looking for Q.
Q.
Q. Okay. So Q is Q, because that's what we're looking for. M is 5.0 grams, or G. C is the specific heat capacity of copper, which is 0.092 joules per gram degree Celsius. So now delta T equals T final minus T initial, or that equals 80 degrees Celsius minus 20 degrees Celsius will give us 60 degrees Celsius. So my delta T equals 60 degrees Celsius. Now here's what's important. What's important now, Q is going to be Q joules, because that's what we're looking for, so QJ. So now I got to make sure that all my units jive. Before I go on, do I have to convert anything?
No.
I've got a J, I've got a G, I've got a J, and I've got a G. I've got a C, you see? So everything is cool. If this temperature was in Kelvin, say, they could throw that at you, then you have to convert it. The conversion for that is also located on page 12, excuse me, table T. All right, now it's just plug and play, right? So I'm going to go ahead and go Q equals MC delta T. Q is still Q, because that's what we're looking for. M is your 5 grams, 5.0 grams. C is your 0.92 joules per gram Celsius. And then your delta T, not your T final, not 80, not 20, your delta T, which we figured out to be 60, is going to go here, 60 degrees Celsius.
Like this way, this way.
Now, over here, we're not dividing, all we're doing is multiplying the thing together. But before we do that, let's take a look and do what we call that unit analysis. The unit analysis is going to make sure that our numbers are right. Not right now. So, the 5.0 grams, 0.092 joules per gram per time Celsius, degree Celsius. Now remember what this 0.092 means with the joules per gram times degree Celsius. That's what that means, okay? So now if we look at dimensional analysis stuff, we could see that the grams goes away here, that gets canceled. The Celsius goes away here, that gets canceled. Does everybody understand what that meant? Right? That's important what I just did. Because that means that I now know that my answer is going to be in J, which is joules, which is exactly what the answer should be in. If I mix this up and somehow I had grams left over, I did something wrong. Okay? You look confused. You look confused.
No, I'm just looking.
Okay, fair. All right, so now I'm cool with the units. The unit's going to be in J, joules, which is what we're looking for, energy, heat. And now I just do the math. So it's just going to be 5 times 0.092 times 60. 5 times 0.092 times 60 equals 27, excuse me, 0.6. So Q equals 27.6 what? Joules. Now, we wanted to talk about significant figures. So let's go ahead and fix this so it's appropriate significant figures. 5.0 grams. 5.0, how many significant figures?
One.
Only one. One SF. So we don't even have to continue because you can't have 0 SF, so why even bother? So we know my answer needs to be in one significant figure, right? Did you see what I did there? Save yourself a minute or two. Why go through the whole unpacking when we know we can't get less than one? So it's one significant figure. 27.6 is in how many significant figures?
3.
3. How would I round that to 1? What would the answer be?
28.
What? Go ahead. No, go ahead. You were right.
So also just round the 20, round the 6. I don't know how to explain it.
Well, then what's the answer?
28.
28? Okay, hold on. So Anaya is saying 28. Q equals 28 joules. Now, 27.6 rounded to the ones, as they say, is 28. Is that too significant? Is that one significant figure though?
No.
It's not. So now we got to round it again to what? 3. Go ahead. It's going to be 30. This is like there you go. 30 joules. How many significant figures is in 30 joules? Only one. How was that only one? Because then, if we flip this to scientific notation, 30 is the same thing as 3.0 times 10 to the 1. 10 to the 1 is 10. 3 times 10 is 30. If you're ever confused that there's a bunch of zeros and stuff, how many significant figures? Flip it to scientific notation. How many significant figures in this? Yeah.
Yeah, Mr. Chris, I get like the significant figures, but it's just like the multiplying the sign, like all of that. The
Which part?
multiplying the scientific notation and subtracting.
From going from this to this.
Yeah.
And then adding and subtracting. We'll do that in a second, yeah. But and again, that's non-intuitive. It's weird. I get it. You know what I mean? Like 20. You're thinking 3, and you said 30, but so you got it. But we got to switch it to 30. Now, if I wanted to go, no, I just want this 3 significant figures. That would be my answer. If the question says give the answer in whatever significant figures, you do not do any of this analysis. You don't go back in and say one significant. Who cares? That's the answer they wanted it. You may have an answer 27.65234. You know how that happens sometimes in the calculators, right? Well, how do you know what to round it to? Proper significant figures, you go back and do that analysis. They tell you 2, 3, 4, then that's what you round it to. Okay? All right? All right, let me stop the video and then we'll do another one. And I got to take Ryan's question.